expert in SDMX, Statistical Data and Metadata Exchange. SDMX is a standard created by the European Central Bank, Eustat, the International Monetary Fund, the Organization for Economic Cooperation and Development, the United Nations, the World Bank, and the Bank of International Settlements to harmonize and modernize the exchange of statistical data and metadata among the international organizations and national statistical systems. In fact, through his professional career, Alessio has collaborated with international institutions and organizations on technological innovation projects and working groups. I would like to thank Alessio for his presence and for his motivation in preparing this session. I hope that, in addition to teaching us a great deal, you also enjoy your stance in Basque Country. Da questo momento il palco è tuo. Grazie mille.
Thank you very much. Good morning, everybody. And just okay, I will try to. Okay, it seems that. Just a few words about the scope of the seminar. The scope of the seminar is to give to you an overview on the most used standards and good practices in the statistical context in order to manage, share, disseminate, exchange the statistical data and metadata. You have to consider that each of the topics that we will see substantially very quickly could be a seminar or a training course by itself, because each of them can be exploded in many specific technical and conceptual details that need a real course for each one. So the idea is to divide substantially the seminar in two parts. The parts related to this morning will cover substantially the general aspect about standardization, the conceptual standard as GSIM and GSBPM, and an overview on the most two used implementation standards that are DDI and SDMX, that in the statistical context are very much used. So, thank you very much. Okay. Yes, but you can also share this one. Sorry, apologies for this technical. Okay. No, because I have seen that it was blocked there. Okay. Thank you very, very much. It seems that now is working. So, at this point, I would start directly with some general concepts about standardization of processes and information in the statistical context, starting from the most frequent requirements at present. All of us know that in the last few years, the official statistic and public statistic has to compare its activity with many competitors, because with the new instruments it's very easy for whatever organization or people and so on to produce statistics by keeping data from internet. You can see also that the Google or other providers now provide statistics very easily. But the point is that the quality of statistics that is provided. And it's real that today users, people ask more statistical indicators with more territorial details because these support the decision activity or economic choices and so on. And another very much important point is the timeliness, in the sense that now we can wait for statistics in real time. So obviously the official statistics very difficultly can arrive to this purpose because there is an activity that implies many quality aspects that need to be covered. But anyway, it's necessary to improve the possibility to make the data available more easily available in very short time, and possibly with the possibility to reuse this data, in the sense to have the easy possibility to take and process with the instruments that the various organizations can have, IT instruments particularly. Okay, another aspect that is important to consider on the side of statistical organization is the fact that now is needed a reduction of costs. So the idea is when implementing new instruments or adopting them or developing new statistics and so on, to not reinvent the wheel. So to reuse components, instruments, methodology that are used in the international context, particularly. So this is a very good approach in order to also to save money, because this is very much important. Okay. What are the issues that usually in all of statistical institutes or in the major part of them happens? There are consolidated but quite rigid processes and methods already in place and implemented for many years. Often there are also IT systems that are not anymore adequate in order to support the modernization of statistics, and in many cases the maintenance of these systems implies high maintenance costs. So the idea is to obviously to take a new instrument, but now in the next part of this presentation we will see that we need to make some specific evaluations. And then there are also difficulties to apply the changes, because are needed new capabilities. For instance, now in the last period there is a very big request of data scientists and other new roles and new capabilities that are needed to increase the quality of statistics produced and disseminated. And there is, in many cases, quite resistance in accepting the changes. So for this reason, in many organizations, including the organization in which I work, that is Eustat, the National Statistics of Italy, have started modernization programs, starting from a specific vision. The vision means what does, in a strategic term, a statistical institute would like to reach in short, middle terms in order to reach a final objective of modernization. Taking consideration very strongly the needs of the users, so for this reason to concentrate the efforts in a user-centric approach, and if possible, it's not easy, but if possible, to adopt an enterprise architecture. Enterprise architecture is an advanced architecture for organization that is organized in layers, starting from the strategic layer, then the business layer, that is the part related to the processes. Then there is the information layer that is specific about the architecture of data and metadata and the flow of data and metadata inside the organization, up to coming to the part related to the application layer. So what are the instruments that we would like to use, particularly in the IT context, up to technical level. Technical level means the software and the hardware that we would like to apply in order to implement these new instruments. So the vision at worldwide level when we are speaking about modernization is related to the idea of to standardize and industrialize the processes with the creation of new competitive products in statistical terms, and this is a very much important aspect, the harmonization of the information. Harmonization inside the organization and also among the organizations. Among the organizations means the possibility to, okay, today it's very, I don't know how to stop this one, because I tried to, okay. The harmonization of information among the organization means the semantic interoperability among the organizations. That means the possibility to exchange data and metadata without losing the meaning of the information that is exchanged among the organizations. The scope is to overcome the stovepipes. What does it mean? In the past and more or less also at present in many statistical organizations, each process is completely organized by itself without any significant connection with other statistical processes. It means that each part, each step of the statistical production is built without taking care the possibility to share instruments, methodology, and so on, but by using a consolidated but specific and old methodology and specific instruments, in some cases developed inside the context of the statistic of the survey that is implemented. This means that there is an important losing of standardization and industrialization of the process. That is the aspect to avoid now. About the cost, we have already told, and the work that must be done particularly is in the management of the information life cycle. So, by this way, what does it mean, modernization? Modernization means two main aspects: the redesign of statistical business processes and the transition to new statistical information system as for reaching the scope that we told previously: common processes, common tools and methodologies, recognizing that all statistics are produced in the similar way. Particularly, the first two aspects that usually are standardized in statistical offices are data collection, in order to use the same instruments and the same approach, and particularly now oriented, very much oriented to the registries, with the use of administrative registries, in order to ask to the respondent the same information that they give for other scopes, and the part related to the dissemination, in order, starting from having, if possible, only one point to disseminate statistics, up to arrive to have a common set of metadata as much as possible, in order to describe concepts that must be disseminated through the statistics in a multi-channel purpose, web devices and other aspects. Not forgetting that in the last year, and at the end of these 2 days we will see some example, the artificial intelligence took place in a very strong way, and obviously it is an aspect that must be considered also in the provisioning of statistics, not to generate data, but to facilitate specifically the access to the data for the users, in order to have very easy instruments to access to data and reuse them in various contexts. So, what can be the main steps for modernization inside statistical organization? Obviously, the first idea is to start from a strategic planning at high-level management, in order to decide what do we want to modernize, and what are the priorities in this context. taking in consideration, as I told you previously, the needs from the stakeholders of official statistics and also the governance framework. Then the decision to adopt, in order to reach the scope, international models and standards. And as you know, this is the scope of this seminar, to have an overview of the standards in order to have the capacity to see and to choose what of those standards can be applied inside the organization. The possibility of integrate new data sources. Now, as I told you previously, there are many new data sources for statistics, starting from administrative registries and also big data, in the sense data that are collected for other scope and are a very big amount of data. Let's consider the data from telephone and mobile companies that can be used in order to analyze and to investigate many specific aspects, not only related to the context of communication and telephone, but also other contexts as position or as other things. But now must be considered another aspect that is very important now, the consideration of privacy about data. This is a very big theme to be considered, has been considered from the beginning by the official statistics, but now there are more constraints because the instrument, the web, the artificial intelligence, the social media impose to have more attentions about these aspects. In fact, also the legislation at the European level changed with the GDPR, also for accessing to this system by the stakeholders and the users. Then the application of digital transformation. There is a big theme in the last period. Use or not use the cloud computing, because the cloud computing has many advantages in terms to manage systems and data without having and maintaining the infrastructure in premise. But there are also other aspects where, for instance, where the data are stored, in what country, the legislation of that country is compliant with the registration, the legislation in our state or in Europe. So this is another front of, how to say, of investigation in order to apply the correct choices. Analytical capabilities also to use instruments that can perform specific activities as machine learning, real-time data processing, and advanced instruments for the visualization of data in various layers and in various channels. And the workforce development in the sense to get the appropriate capabilities in order to modernize, as I told you previously, to recruit data science experts, experts about IT systems in the context of the web and the development, the service-oriented development, and the experts in information security, in IT security, and also in privacy regulation. That are two skills that, how to say, complete each other in the sense there is a technical part, but also the part of regulation and legislation. The high-level group for modernization of statistics, HLGMOS, has developed a model in order to do this that allows to make an assessment if an organization obviously would like to understand if there is the possibility to modernize and what is the arrival point, what that can be sustainable for that organization. So it's possible to use this maturity model that has been developed by the HLGMOS, High-Level Group for Modernization of Statistics, that is chaired for the UNEC, that is the Statistical Division of United Nations. And this model can allow a statistical organization to assess the current state in order to understand the as-is situation, identify eventual gaps, so areas that need to be improved, and the possibility to provide a roadmap with the idea to reduce risks. I hope it will be possible to me to reach in the link the page of the modernization of maturity model that, as you can see here, is very strictly connected to the conceptual standards as GSIM for the processes, GSBPM and GAMSO for the processes and for the strategic activities, GSIM for the information models, in order to modernize the statistics. And if we go in this subsection related to the roadmap tools, it's possible to check the aspects that need to be modernized. And specifically, there is a template for the assessment in which there are dimensions that are business, methods, information, application, and technology. And in some part of this, there is also the possibility to see what are the states. Okay, I don't still checklist. Okay, the states of the level of the model that you can put substantially a value starting from the current maturity to target and so on. Then there is a section for the recommended practice in which it starts from a checklist about the skill in the organization. In order to understand what are the professional profiles and the knowledge required for applying the systems, the standards, particularly GSBPM, GAMS or GSIM, that are the conceptual standards, and obviously to assess the as-is situation. Then there is a checklist for the implementation in order to understand what is the state of organization about the standards, if there is a situation of initial awareness pre-implementation up to arrive to corporate implementation, with the related checklist in order to make a more detailed choice. And then there is an evaluation template in which for this of the of the dimensions that we have seen previously, business, method, information, application and technology, it's possible to put an evaluation about the state of implementation of the standards that we have seen. The same is for the consolidation template, that means the list of actions needed to ensure stabilization and new practice about the application of the conceptual standard inside the organization. And then a template for the lesson learned in order to take trace about the challenges, benefits in applying the modernization based on the conceptual standard. But anyway, you can go inside this part and then to check in detail the various parts. Now, after the modernization, we can explore the aspect related to industrialization. What does it mean? In industrial terms, means the possibility to produce all the same, every time the same. So to have repeatably processes, in this case, in order to produce statistics with constant quality, without losing quality from one stage to another, and in as much as possible short time frame, because as you remember at the beginning of this session, I told you that timeliness is a very much important aspect, because if we are not in time to provide statistics, someone else will provide for us, but it is not official statistics. There is the idea to design the processes and also the application that must be separated from execution, from putting in production these processes or this application. And less human intervention, not obviously to exclude the people, but with the idea to improve the quality of the processes, because some activities made manually can could include errors on something similar. The industrialization is needed for effectiveness and efficiency of the processes and of the products. What are the industrialization, can be the industrialization steps in a statistical organization? First of all, to pass as much as possible to use registries for industries, the business registries, but also registries for population and so on, administrative registry. Then standardize processes and methodologies with the adoption, as we have seen previously, of international standards. Model questionnaire in a standardized way. Later we will see how does it mean, for instance, by using DDI, the Data Documentation Initiative, that covers the possibility to create questionnaire and to reuse the meta information for many different questionnaire, and the use of harmonized concepts. Also in this case, the standards and the implementation standards could be very useful for us, specifically DDI, but also and more SDMX, statistical data and metadata exchange. In industrialization, it is important to consider the automation of data collection and processing. Also for processing, in the last period has been defined a specific standard that we will not see in the, not to say in this seminar, but it is anyway very much important, that is VTL, Validation and Transformation Language, that is born as a part of the SDMX standard, but now is substantially an autonomous standard that can be used in order to model the processing rules for data in various stages of the statistical production. Implementing quality management systems, and here I put some possible examples about that. Enhance data analysis and dissemination by the production of industrial performance indicator, and the use also for monitoring the processes of visualization tools and dashboard. And we have told many times today, build the capacity and the governance. So this means to improve the capabilities, to recruit new professional skill, to how to say, to train the present staff in order to to use new technologies or apply new methodologies and establish a governance for the confidentiality and the metadata standards. Standardization enforces the consistency and or uniformity to certain practice or operation through a well-consolidated and time-tested process. It is very strictly connected to the industrialization, but anyway is, how to say, a concept more related to the possibility to have a common, as much as possible, common processes and common methodology. The standardization can guarantee the improvement of operational performances and cost reduction, less processes error, and this is the last one, because the other one we have seen also previously. The last one is very much important, that is the interoperability, in order to allow a statistical organization in this context to make available data, obviously in an open format, but also with the possibility to not lose the meaning of the data when they are made available and taken by another organization. The use of the standards helps because by this way it's possible to exchange meta-information very easily and to reuse this meta-information in various organizations with the possibility to exchange data among organizations, put available data to the stakeholders, and to allow them to use the metadata made available in order to interpret correctly the data. This facilitates also the communication about these aspects. As far as concerns the steps related to the standardization are the following. Define clear objectives in the sense what do we want to standardize firstly. For instance, and what are the scope of the standardization? For instance, improving data quality, enabling interoperability, and so on. And as I told you previously, which domain processes should be standardized in a priority way. Adopt international standards, but this we have told also previously. Develop standard operating procedures, and by this way, the application, for instance, of the GSBPM for the processes is very much important in the statistical context. Harmonize data formats and structures. This implies two levels. A level of design of data structures and to be applied to statistical concepts. And by this way, we will see, for instance, that SDMX could be very useful in this context. And use as much as possible international classification an international naming convention for variables and for classification and categorical values. So substantially, in one word, the keyword is the reuse. So the idea is, as much as possible, to reuse best practice and to reuse data and metadata and methodology and processes supported by the international standards. What is a standard? A standard is a document substantially containing specific rules to be adopted in order to be compliant to the purpose for what the standard has been created. The example of standards that we will see in the seminar, as I told many times today, is the GSBPM and GSIM as conceptual standards. GSBPM is Generic Statistic Business Process Model, and the GSIM is Generic Statistical Information Model. And then two implementation standards. What does it mean? The conceptual standard cannot be directly implemented, for instance, by a system or a software. The implementation standards can be implemented because they have information models and rules that can be applied inside an IT system. So, and they are SDMX, Statistical Data and Metadata Exchange, and DDI, that is the Data Documentation Initiative. This is substantially a graphical representation of what we told up to now. We have the classic chain of processes supported by, for instance, by the GSBPM: collect, process, analyze, and disseminate. And this is the representation of the stovepipe for the various surveys. So each process is organized in a different way as far as different statistics, and they use its own IT processes. Obviously, in this context, it's very difficult to standardize and industrialize the process in the statistical organization. So this is the scope of modernization. So to have a very uniform and integrated, as much as possible, integrated situation for each various steps. As I told you previously, in the major part of cases, the aspects that are modernized firstly, also in organizational terms, are data collection and data dissemination, because honestly it's more easy to start from them. But the purpose is to use the same approach also as far as concern the part relating to process and analyze. In order to arrive to build substantially some building blocks that can be combined in order to build a specific workflow related to a step or related more big workflow related to all the chain. This can help other organizations in order to be compliant with this approach, because it's possible to get building blocks and to apply to a specific process. When I speak about building block, I speak about methodology, I speak about IT functionalities, particularly in terms of implementation IT services, and information. So in order to standardize the flow and the process of information, has been necessary to use a standard for define the interfaces for each process, for getting the input, the information in input, in the output, and how inside the process the information flows and can be processed, transformed, and disseminated in some cases. Okay, this is just to let you know what is the high-level group for modernization of official statistics. Is chaired by UNSC, is composed by 12 members, which there are international organizations, Eurostat, OECD, and some national statistical organization as Australia, Canada, Italy, Mexico, Netherlands, New Zealand, and so on. The idea is obviously to promote modernization in the worldwide context and to provide standards, instruments, and best practice to do it. In addition to the standards GSBPM and GSIM and GAMSO, there is not properly a standard, but a template architecture, that the common statistical production architecture, that has the idea to give guidelines and as possible to provide instrument to create a service-oriented architecture inside the organization by the possibility to define the rules for building each building block in terms of application combined with information and processes. And these are the most projects that correspond to the standard and to architecture that I told. As far as conceptual implementation standards, I already explained this concept, because conceptual this is concept that is important to repeat. Conceptual standards are standards that cannot be directly implemented, but need the implementation standard connected to them to be implemented. GSBPM and GSIM are conceptual standards. SDMAX, DDI, and other standards as DCAT for the creation and publication of open dataset catalog in the context of in the public context at European level. And in technical terms, the most important best practice is to build a service-oriented architecture based on web services in order to create the appropriate functionalities to flow the data and so on. Okay, and here we have the specific references about it. So this was the introductory aspect. I don't know how we can do, if are there eventually questions, or we make the question at the end, if someone of you has some question. Okay.
Maybe later.
I hope.
Sure.
I hope.
I can assure you that.
Okay. So let's, if there are no specific questions, let's go inside. Let's start to go inside the various standards. Starting from
I have the program here. I suppose we have 10:45.
Okay, so we have 3/4 of hours. I hope.
Can be a bit flexible.
Okay,
Sure.
yes, obviously. Yes, but I have to consider that it is quite heavy also for the people hearing all this information. So, okay. Now we are going to start the first specific topic related to conceptual standards that are GSBPM and GSIM. With an overview of them, obviously, we cannot go too much in detail about these standards, considered the time that we have. Let's start with the GSBPM. GSBPM is the generic business process model, and it provides a standard framework for model statistical processes and sub-processes at various levels. It starts from a main level. Now we are going to see that consider the classic steps related to design, collect, process, analyze, and evaluate, and then goes inside this process by the definition of set of sub-processes that can be implemented inside a survey or statistic. Just a brief history. GSBPM obviously started from a previous former activity of consultation in the international working groups at the European level, and not only, because GSBPM has been created also in the context of high-level group, so for modernization of statistics, with the idea to support the modernization in terms of industrialization and standardization of processes. The official start has been put in place in April 2009, in which the version 4.0 has been released. Then in the December of 2013 has been released a new version with the 5.0, in which the most important aspect has been the the relationship and the strict connection with the other conceptual standard, the GSIM, for the information. In February 2017, this standard has been approved at the European level by the European Statistical System Committee, and in January 2019 has been released the new version, that is the present version, the 5.1. Has been developed in the field of METICS task force inside the HLG MOS. And METICS task force, that is the task force of the level group that is implied in the definition of standards and best practice for metadata. And for 2025, the main task activities were related, because we are considering that this year is finishing, about the interoperability with SDMX and DDI, because, as I told you, these two standards can implement aspects related to the conceptual standard, and to the consolidation and definition of the statistical architecture framework, and also the revision of the other standard connected to GSBPM, that is GAMSO, that is at higher level than respect to the GSBPM, but now we are going to see it in detail. This is the model of GSBPM, in which you can see in blue the main processes, from specify needs to evaluate. And for each process, we have a set of sub-processes. For instance, we can see in the design output, variables, defining the variables to be investigated, the design the data collection, with the frame or the sample to which submit this data collection, and so on. And this is valid for all of the main processes. And then we have also a set of overarching processes that are those one: quality management, metadata management, that are valid for each of the main process or sub-process that we have to consider. So quality management, metadata and data management, process data management, knowledge management, and provider management. And you have to consider that it seems to be linear. And if we consider this scheme, so it starts in cascade, it seems to be in cascade from specify need to evaluate. But this is a flexible model, because in the organization it's not necessary for applying this model to implement or perform all the sub-processes. And the order the sub-processes can be different from the one that we have seen. It is possible also to connect some sub-processes with the jumps, so avoiding to apply in the middle other sub-processes that are indicated in the model. it is possible to repeat some steps, so to create substantially some cycle, and it can be considered substantially a sort of matrix. Here we have an example in which you can see that there are some jumps, for instance, in specified needs, in which not all the subprocesses are considered, and then from evaluation there is a feedback for data collection. So substantially it is possible to define a loop, because after the evaluation, obviously, it's possible to implement some improvements in the various sub-processes in order to get a more improved result in the statistics. And there is the possibility, is the same, for instance, in the process, edit and inputs, and then variable outputs, in the sense that I check the output and then I come back to the input in case, in order to see if there are errors or other problems in terms of content or in terms of syntactic errors in the data that I'm validating. Okay, as I told you previously, very strictly connected to GSBPM, that is at the level of business processes, there is another conceptual standard that is the GAMSO, Generic Activity Model for Statistics Organization. This is at higher level and covers aspects related to strategy and leadership, for instance, define vision, govern and lead, manage strategic collaboration and cooperation, and also the part of capability development and corporate support, up to go to the part related to the production, that is GSBPM. Substantially, here you can have the complete vision of the combination of the two conceptual standards. As far as concern GSBPM, the main processes and sub-processes can be divided into some areas. The first area, specific needs, design and build, is the area related to planning, but I can see to plan and design. Then there is the part of production, of realization, that contains the processes and sub-processes for collection, for data processing, analyzing, and dissemination. And at the end, we have the part related to the evaluation of the process, so substantially the part related to the assessment. As I told you previously, substantially we don't have to see the GSBPM model as a cascade model, but it is preferable to define it as a sort of loops that allow to continuously improve the processes for a specific statistics. So the design and build, specify need, design and build, go to the part related to the production, to the collection process, analyze and disseminate, that can be whose result can be important in order to improve some aspects, so to come back to the part of the design and build, and by this way to continuously improve the process, the whole process. Coming to the specific sub-process, starting from the specify needs, this means this with its related sub-processes means the interaction with the stakeholders in order to capture the expectation, the requirements for the statistical production. In addition, obviously, to request by a regulation by international organization, for instance, at European level, from Eurostat for the production of statistics. Identification by this way of the needs for implementing a new process or for improving it. The design and definition of high-level solution and the final approving by the senior management. And this is, and here we have the details. Specifically important is the consideration that in this work the main aspect is the definition of the concept, so the characteristics of a population that need to be investigated to reach the scope. And then by this way, the phases that we have seen. Then there is the part related to the design that starts with the design of the result that we would like to disseminate or to exchange, so substantially the design of the outputs. And then the phase related to the connection, the collection, sorry, with the possibility to design the sample or the frame to apply, to submit the survey. And also design the production system or workflow, or identify system workflow functionalities that can be applied in these statistics. So by this way, in a few words, the definition of methods and of tools. Then as far as concern the part of the build, build means to put in place the survey by deciding or using or building the collection instrument and the process and analysis components, configure the workflow, make obviously the test of the business processes and the production system, and finalize it in order to pass to the part strictly related to the collection. This part is modeled usually with the idea to consider whatever the source of the method that that is used. Obviously, each one of these steps in the application of the GSBPM must be described in order to have at the end the description of the whole process. As I told you, this is not an implementation standard. As far as concerns the process, it is related to the part of data processing, treatment, aggregation, and other aspects, up to the production of macro aggregated data that usually is the result of the statistics of the survey. Then there is an analyze phase, substantial the validation of the output, the check of the part related to the confidentiality, eventual integration of outputs in order to obtain more complex output and analyze the whole situation about the integrated outputs. And at the end, the dissemination, that means release of specific outputs with the decision of instruments and application of instruments for not decision, because decision is the design phase, but application of the instruments for dissemination or data exchange or reporting of the data to the collectors. And then at the end, there is the part relating to the evaluation. As I told you previously, the evaluation of the outputs, but not only, also of the process that can be as much as possible monitored, can be an input for next edition of the statistics in order to improve some specific aspects. Then, as far as concern the most used overarching processes, as the most important overarching processes are quality management, that is used to assure that quality is applied. Later we will see what does it mean, the application of quality to the survey process. But the quality of statistics is guaranteed among all the steps of the statistical process. Metadata management, this part is strictly connected to the other standard, that is GSIM. Obviously, if it is considered also at higher level and strategic level, it should be modeled also in GAMSO. And then the part of data management, also this part is strictly related to GSIM and to implementation standards, particularly SDMX and DDI that we are going to specifically check. Where it is possible to apply the GSBPM? Obviously, in the standardization of the processes, because applying a standard model facilitate the implementation of standardization also at level of application, IT systems, methodology, and so on. And the possibility, this is important, and I continue to underline, to reuse all these processes also in other statistical concepts. This is very, very much important, because the idea of reuse is at the base of standardization and industrialization. Another very much important aspect is related to the creation of metadata-driven processes. Particularly tomorrow, when we will have to explore the use of SDMX, we will see in practice what does it mean. It means that the system are based on the metadata that they are using, and the functionalities are driven by this metadata. For example, we will see that in the same system, it is a system SDMX based, the meta and data manager that we developed in Eustat, is possible to model a data set, so create in SDMX a data structure definition, and then in the same system consume this data structure definition for creating at database level, so physically inside the database, a multidimensional hypercube without going to the database administrator or the database expert and see, I need this table done by this way. So he writes the SQL, the statement, in order to create the tables and the database that we need, and then we can ask him to provide other functionalities for importing and managing data. We will see that the system Meta and Data Manager will do for you with simple user actions, without, in a transparent way, without going to technical level. And this is driven by metadata, by the data structure definition that we have created. That is a parameter in this case. I can create whatever hypercube based on the structure that I submit. And this is a very much important aspect in this context. Okay, then the quality indicators also are mapped in each sub-process of GS BPM, and you can find in the document indicated here all the specific details about the quality indicator as consistency, timeliness, and all of the aspects that define the quality, the coherence, the aspect of that define the quality in the statistical level. Okay, now just to give some small idea of an example of the application of GSBPM, for the main process, let's say, what does it mean? Starting from the specified needs, in which this process is used for identifying user needs and define objectives. In the context of label market indicators, it could mean the determination of these indicators required by the policymakers or the stakeholders. As far as concerns the design of statistical processes and methods, it can mean the context of the labor market indicator, the development of the questionnaire, and the design of sampling for the labor market survey. As far as concerns build and test the production system, it is written here, create data collection tools. Not only create, but choose if create or reuse, considering that are available many instruments, standard-based and open source and free of charge, and then test the instrument selected or created in your context. Then there is the collection for the labor market indicators, so the conduction of interviews on the basis of various instruments, submission or of paper or online questionnaire, and or create conduct interviewers and get the responses from the households. Then process, so validate responses, handle missing data, process the data, and prepare the dataset macro aggregated, and analyze the processed data in order to produce the final results. And then at the end, disseminate the result to the users by using the instrument that we have designed or chosen in order to disseminate the data. And at the end, evaluate the result for future rounds, substantially for future edition of this statistics by labor market indicator. And as far as concern the sub-processes, okay, this is a small document that is a template that can substantially reused in order to implement a single subphase. This is related to the subphase of sorry, I have to, if I'm not wrong, to stop this presentation. I click. Okay. Yes. Apologies. I suppose that now you you can see it. So this is an example, a template that can be used for one of the sub-process and specific the sub-process related to the process of design, and the sub-process 2.3 design collection. This is a template of the document that can be written in order to model this sub-process. As we can see, we can start from the purpose in which is possible to define how data will be collected, the models, instruments, and operating procedures, and with the idea to ensure alignment with statistical objectives, and this is important, minimize the respondent burden. For instance, I told you previously that have to be considered also in the possibility to integrate with other data sources as administrative data sources. The description of the sub-process with the specifying the approach for collecting data, the collection mode, if it's online, telephone, face-to-face, the design of questionnaire or data capture form, and the operational protocols for the collection. And then the definition of the inputs, the sampling frame, the metadata standard and quality requirements, and also the output with the detail of the data collection plan with the related periodicity. This is important if it's a monthly, quarterly, or annual collection. Draft questionnaire or electronic instrument, the protocols for the collection and the guidelines for the respondent, and eventually updated metadata documenting the collection design. This must be updated for each cycle that we have to consider. Then the activities that will be performed, the selection of the collection mode, as I told you previously, also based by the instruments, and more the target population that we would like to reach for the questionnaire. Draft and test questionnaire or form, and define the instruction for interviewers, and establish procedure. This is also important for follow-up and the management of no response. Then the indication of tools and methods that will be applied. As far as the tools, the indication of the questionnaire design software, the cognitive testing, and also pilot studies. We will see particularly in DDI now, when we will define in detail the study and the document that can be created for defining a study that is substantially a survey. the metadata management tools that will be used, and the guidelines for accessibility and usability of the questionnaire, and the quality criteria application, so the instruments tested and validated, the collection mode suitable to population and objectives, the documentation that has to be complete and traceable, and last but not least, the compliance with the confidentiality and legal instruments. And then the transition condition, so the relationship with the next sub-process once the collection instruments are designed, are finalized, tested, and approved, and the metadata are updated. You have to consider that similar templates can be used, obviously, for each of the sub-process that we can consider. So, these are the main aspects related to the GSBPM. Obviously, the model is very rich, so you can have the possibility to go on the HLGMOS website in order to keep the detailed information of the standard in order to eventually evaluate and apply it. So, okay, I don't know if are there specific questions about this second topic. No? No? Okay. Then...
I have a question myself.
Okay.
Yeah. Well, I had two, but one of them was the metadata-driven processes, but you told that you are going to explain them later, so I will skip that. But the other is regarding the reuse. If GSBPM is considering a conceptual model, how do you handle the reuse of parts that are conceptual in terms of...
the reuse in this context means the possibility to keep, for instance, at the international level, other descriptions following the templates that we have seen of the processes in which are indicated the instruments, the methodology, and all the aspects related to these sub-processes. Also the schema with the relationships among the various sub-processes. So, as I told you at the beginning, that not all sub-processes can be used. So, there is the possibility to define workflow. Other organizations can have adopted a set of sub-processes and then used the part of them. On internet, there is the possibility to check some examples. For instance, I have seen one from Australian Bureau of Statistics. I suppose there is something also about Statistics Canada and so on that are very advanced in this context, in which you can try to keep this documentation and try to develop something similar in your context. It is a descriptive standard. So this could be the approach, and then the choice is how to implement all of this. But this is the next step that we are going to see in between today and tomorrow. Okay, if there are no other questions, I suppose that is the hour for having the coffee break. So we will meet again here at 11:15, if I'm not wrong. Okay, see you later. Okay, now let's start this second part of the morning by speaking about the other conceptual standard, specifically related to the information, that is GSIM, Generic Statistic Information Model, that is the first international endorsed reference framework for statistical information. It provides standardized definition, attributes, and relationship for information object used in official statistics. And we will see that there are many objects that have been modeled inside this model, divided in 4 main areas. The standard enables generic description of data and metadata through the statistical production processes. The purpose of GSIM is to be used for foundation and collaboration inside inside an organization, a statistical can allow other organizations to reuse the same information objects in their processes. For this reason, it improves communications and data and metadata exchange among statistical organizations. What are the main use cases related to GSIM? The metadata management for survey and statistical programs, the exchange, as I told you before, the exchange of data and metadata between organizations, and also the documentation of changes about classification, and particularly international classifications. The overall architectural scheme of GSIM is the one that we see here. We have objects divided in 4 thematic area related to business, exchange, structure, and concepts, and now we are going to see more in detail what does it mean. And there is also in this case an overall level that is the base level for the objects that are common for each of these areas. Specifically, the areas in GSIM are the groups, and we have business, exchange, concept, and structures. And in each group, as you can see, we have a set of main classes that are used for modeling information, that are those that we can see here. And now we are going to have an overview of them in detail. As far as concern the business group, we have a pair of very much important functionality objects. The statistical program intended as the set of activity necessary for implementing a statistic survey inside and that are used in the statistical organization for a specific statistic. And this statistical program is linked to an object that is the statistical program design, that is the part related to the design, the project of the statistical program, the project of the survey, substantially. And it is connected, the design, the statistical program, to a set of business functionalities through which is possible to determine the business process connected to the statistical program. In detail is related to the statistical program cycle, taking in consideration that we can have, as we have seen in GSBPM, many editions about a specific survey or statistics. So for this reason, each of them can be considered an edition of a general statistical program that can contain many editions. So the statistical process is composed by a set of business function and that is connected to a process step. A set of process steps substantially determine the complete statistical business process. The process step can consume the business services and is determined by an input and an output specification. And this part, the input-output specification and the information related to the process step and to the other higher level, the business process, the statistical program, is the information that we have to model as far as concern this group of objects. This model is represented as a UML model that can be seen in this schema for the representation of the connection among the various entities in a model, in an entity relationship model. So, as far as concern the statistical program design, it is based on a set of business function that can be based also on specific patterns that are, or models that are process patterns that can be used in order to design the various business functionality, through which is possible to define the process design that is as a central element, the process control design, that is the element that models the flow of the information inside the process and is based on specific rules. These rules are determined by process methods that are implemented substantially in the process, in the designed process. And then there are the input and output specification, as previously I told. As far as concerns the concept group, the central element is the concept that we can consider substantially as a unit of thought and of specific characteristic that is used, is investigated in the survey on a specific population. So the concept can be can have specific roles and specific characteristics. So can be implemented as a conceptual variable that is the description of the concept without any association with the values that the concept can have, can be described on the population, so the set of elements that is investigated about the characteristics that we are considering, or unit type or category, in the sense that category is a conceptual value that can be applied to the variable, not to the concept variable, but to the represented variable. And here we have the representation of the universe that is substantially a conceptual representation of the population to which we would apply the investigation, the survey. And then the population is composed by single unit. Consider the population and the persons, for instance, as a unit of the population. And then there is the concept that is the representation of the characteristic of the population that is investigated in the survey, with obviously each of them has a specific relationship. The conceptual variable is connected to the concept. It is not associated to values, but is associated to a conceptual domain, and is used for measuring a specific unit. Conceptual variable can be related to concept, general concept for a person as age or marital status and so on. And each of these variables can be connected to a conceptual domain. That means how to say, the set of possible values that this variable can have, but not values in measured sense, but conceptual set of variables. In fact, there is the possibility to consider the described conceptual domain, which is the description. For instance, a domain related to age could be the domain of people that is pensioned, in the sense that has an age related to the pension. And then there is the enumeration of specific values for this category, this group, that is the set of values of the age for this this conceptual domain. Oh, sorry. The represented variable is the representation of this variable associated to a specific enumerated set of values for this variable. For instance, the single ages in the case of the age. This enumerated set, it can be associated to a set of, is associated, in considering enumeration, to a set of categories. When these categories are associated to a code, these categories can be also called code lists. And then the code lists can be associated to specific represented variables. And then we have the instance variable, that is the represented variable when is associated to a data set. And a data set is composed by a set of instance variables whose combinations determine a data point. A data point is substantially a placeholder, in a physical representation is the value of the data, but in conceptual term is a placeholder that represents the datum, that is the effective values that is applied to the data set. So the represented variable is associated to a value domain. For instance, each of the variables that we can consider, territory or age or marital status, if it is represented as a represented value, is associated a value domain that can be enumerated in the sense that we have a finished number of elements that can represent the value for this represented variable, or is not associated to a set of values. In this case, it can be considered a described, associated to the described value domain, in the sense that we have values that are represented by a description, by, for instance, a simple text. So, in this case, for instance, we can consider a statistical program that can be a census about the population of and households. The unit type can be person or household, in this case household. The universe that we are considering is the household residing in a specific place, and the population is households in Italy for a specific year of the survey. As far as concern the one of conceptual variable, we can consider country of residence in this case, and the value domain can be the set of the countries. For instance, we can have a code list with specific values at IT for Italy or other values for other countries. And for the data set, we can have a data structure that is composed by a set of instance variable. In this case, we have the example, the country of residence of Italian households for the census 2020-25. And on the last column, we can see in what group of GSIM these are placed. For instance, the statistical program in the business group. In the concept, we have the unit type, universal, population, conceptual variable, and value domain. The structure of the data set in the data structure. And also in concept, we have the instance variable that is used in the data set. Then we have statistical classification that is an entity that takes the values from an enumerated value domains, but the classification has two specific characteristics. The first characteristic is that the elements, the values contained in it are mutual exclusive. There is not possible to have overlaps. And the other is that the value domain related to classification has to be full and completely inclusive of all the elements that are needed. So it's omnicomprehensive. So in this case, there is enumerated value domain that is at more conceptual level. If it is coded, it is associated a code list. Code list is similar to the classification, but the difference is that usually it doesn't fit with the two main characteristics of classification values. So the mutual exclusivity, the fact that the values must be mutual exclusive, and the values must cover all the possible values that are needed for the value domain. Furthermore, another characteristic is that the code list usually is not hierarchical. Instead, in the classification, very likely there is a hierarchy with the specific levels. So we have the set of elements about the classification code list and category sets. The difference among category set and code list is that category set is similar to the code list, but it hasn't coded value. Also only, description for the category items. When they are associated to a code, we have code items, then the set of code items is a code list. And the classification items are the values for the classification with the rules that we have already told. The statistical classification can be grouped in classification series. For instance, you can imagine the classification of NACE, the classification, international classification for economic for economic statistics. This classification has various editions because in the various periods have been issued some different instances of this classification in which have added or cancelled specific items. And this set, for instance, there is the NACE 2007, but there is also the NACE 2002. So there is a set of this classification that the set of them compose a series in which there are various editions of those. All these series determine a classification family, that is the classification, for instance, of the economic activities. So this is what I said. The classification family is the economic activity. The series is the NACE. A series is composed by various instances of the classification as NACE 2007, and this classification is a hierarchical in which we have 4 levels. I suppose that there is another that is the fifth, the 5 digits. There is the section 1 digit, the division with 2 digits, and this is the example: 1 digit agriculture, 2 digit crop and animal production, 3 digit growing of not perennial crops, and 4 digit growing of cereals except rice, and each of them represent 1 level: section, division, group, and class. And all of these aspects are modeled in the GSIM. As far as concerns the group related to the dataset, the central element is the dataset, that is the set of data points that are structured in a consistent block of data. The data set is structured. This we'll see in detail when we will see DDI and specifically SDMX that translate very strongly this concept in structure that can be processed by the tools. The data set is composed by data structure, And we can have two types of data structure: the dimensional data structure that is used for modeling multidimensional data sets, particularly for aggregated data, and the unit data structure that is related to the structure for modeling elementary data, unit data. And so the data set is composed by a set of data points that are placeholders for the real value that is the datum. A data structure is composed by various components. The components substantially are concepts to which has been associated a role. Specifically, we can have identifier component that in the multidimensional model of data are substantially the dimensions. Then there is the measure component that represent the component, measures component, the component for containing the values, the data points. And then we have the attribute components that are related to concepts that are not identifying but are descriptive. For instance, in a data set, we can consider attribute as observation status or confidentiality status. These attributes are not identifying because changing the value of this attribute doesn't change the record that I identify. Instead, for instance, if I have a combination of territory, how to say, sex, marital status, country of provenience, and so on, if I make a combination of them, I identify univocally, specifically a datum, a data. In this case, these are dimension, these variables that I told, and are identifier components. Attribute means that I don't identify a data point, but I give to the data point a specific characteristic that is used for understanding the data point that I'm representing. And the data structure definition is composed by concepts that are expressed as represented variables. And this is the more synthetic representation in which I have the data set that is structured by the data structure. This important aspect to be considered for each of these elements is their use. For instance, I can use a data structure for structuring many data sets, not only one, because you remember when at the beginning of this morning I said that for industrializing the process, the design must be separated by the implementation. So the data structure designs the structure of the data. And then, by this way, it gives a role to specific concept that in the data structure is called the component. The component can be role identifying measure or attributes, and this is applied to the data. For instance, for people that is expert of database. The identifying components compose the primary key of a table. So by this way, it means that the combination of this variable, the values of these identifying components of these concepts represent univocally a data point in a data set. But the data structure can be applied to many data sets. For instance, I can make a data structure for, and is used in Eurostat, a data structure for short-term statistics. So this data structure can be applied to industrial production, industrial turnover, and other, how to say, and other short-term statistic with the same structure, in which obviously the values that are used can be different according to the data set that I would like to implement. So the same concept is valid also for code lists, for the classification. The reuse is the keyword, in the sense that defined ones use more. In the data structure, we don't replicate all the classification of all the code lists associated to the components, but we reference them. So we say the code list associated to this component, to this concept, is that. At this point, obviously, the data must to be compliant, the data values, the data set values for the column of that concept must be compliant to the values, to the items that I have in the code list. Otherwise, you will see tomorrow with the sample that I show you, it will happen that some data can't be imported, can't be stored, because, for instance, for a specific component, have a value that is not contained in the code list. Okay, this is an example of a unit data structure in which we have a unit type person. The population is individual residing in Italy in 31 December 2024. And the represented variables are fiscal code, income, gender, marital status, and so on. And this is for elementary data, for data. Also in this case, obviously we can have, if we model with the data structure, the identifying component. Identifying component in this case can be fiscal code, for instance. In fact, identify, and then I have a specific measure for that person, income, measurement, unit, and gender, and then I can have, gender and marital status, and I can have attributes for data quality and measurement unit. For a dimensional data structure, I have the structure of the data represented in this aggregated table, in which the unit type is the household, the population is household residing in Italy, and the represented variables are all the variables that we find in the table and in the filters over the tables. For instance, territory, household main income source, and annual average household income, and then the time, and here in the as a value we have the population, the person as a measure corresponding to the combination of the dimensional variables. Measure is the indicator, and the values are in the body of the table. Indicator is annual average household income. The identifiers are territory, household number of components, time, and then we have the values, and the attributes are those one that are not represented, but very likely are values that indicate OBS status that indicates that there is not value for that period for that indicator. Okay, there is finally the exchange group. The exchange group is related to information entities that are used in the data and metadata exchange. And substantially, there is an important element that is the provision agreement. The provision agreement is a sort of a contract among the data provider and data collection, in which are indicated the exchanged specification, the specification, for the exchange. For instance, in SDMX, we have the indication of the data set, we have the indication of the values for dimensional components of the data set that can be used in the exchange. So if we have, for instance, the dimension that is territory, if the agreement is based on the fact that we don't have to exchange all the values for all the Italian territory, but only for the regions, it means that there will be the association in the provision agreement among a data set and a set of entity called the constraint that indicate what codes can be exchanged, data about what codes for specific represented variable, substantially specific components that can be territory or other components. Furthermore, another information is related to the aspect of the mechanism of exchange. For instance, the periodicity of exchange that can be taken in consideration and must be indicated inside the provision agreement. And we, in standard as SDMX, this entity is used in some registries for supporting the data collection by international organizations, for instance, Monetary Fund, that uses the provision agreement with the organization participating to specific exercises like the macroeconomic data collection, that is SDDS plus exercise, in which each member organization, together with the monetary fund, define a provision agreement, and automatically the system, on the basis of the provision agreement that determines the period, grabs the data coming from the various organizations that are exposed as a file or as services or as web services. Okay, GSBPM and GSIM obviously are strictly related, and they are complementary in a certain sense, in the sense that with the GSBPM I can define the processes and sub-processes, and with the GSIM I can define the objects representing the information that is an input for the GSBPM process, is an output, and also the information that is processed inside a process, a sub-process in GSBPM. So we can see that this integration in more detail is represented by this way. So this is the representation of a sub-process in which there is an input that is composed by a set of data objects related to the core input type, that is the information that is the real input for the process, a set of parameters that can be associated to this information, and also them are part of the process input specification, and other information that technical or information supporting the process. Then there is the representation of the process, sub-process in GSBPM, in which there is the process design, that is the element describing the process, the method, and the process control design. The control design means we will see in DDI the representation of the flow of the steps for implementing the process. In a questionnaire, you can, when a questionnaire is submitted, the control design is represented by the flow of the questionnaire that can be processed according to the fact that if it is not responded at row 4, skip to row 10, and then return to. All these aspects are designed in the process control design. That is based, together with the process method, on a set of rules that can be applied. And then there is the process output specification that as input is composed by a core output, that is the information that flows outside of the process, a log that represent the execution of the process with the result, and the process metric. for a specific phase that is process data processing, we can find the integration among GSBPM and GSIM, in which we have in blue the part related to the sub-process in or function in GSBPM. In green we have the part, the entities of GSIM at various levels. Level of component that is green, and we have in yellow the part related to the data structure and the data set. This is just an example on how they are combined for the various sub-processes. So this is the part related to GSIM, and with this overview we conclude the aspects related to the conceptual standards that, as I told you previously, are cannot be implemented. But now we are starting to see the part related to the implementation standard with DDI and with SDMX. But before doing this, I don't know if is there any question or clarification or
Maybe there are no questions. I have just one. I have the feeling that the GCIM in the end is the ontology of the statistical information. I mean, somehow I have that feeling.
Substantially, it can be considered a set of entities that can be represented as an ontology. Unfortunately, not directly by this standard, but yes, for implementing represent a model substantially of object that can be implemented also as a linked open data, considering the possibility to, to model them. You can consider that substantially also SDMX can be seen as a set of the implementation of a set of ontologies, specific ontologies. So yes, the answer is yes, yes. Okay, please.
There is a question over there. They can handle the microphone.
Hello. Yes, I have two questions. Maybe easy to do, but not so easy to answer. First one is, I see all the processes, sub-processes, all the definition, all the things you have to do, and how long can it take to do all this schema, to do all these steps for one survey, for example? And the second question is, who should do it? I suppose there is a group of stakeholders or people who have to do it, but mainly technical people that afterwards does data collection and data analysis, but also the leaders of the organization, or who should do it?
Okay. I'm sorry.
Okay.
Okay. Suppose.
The green light. I didn't see the green light. You didn't see that? No.
Okay. No, it's green. Okay. First question can be answered by this way. You remember that at the beginning I said that it's not necessary to implement completely all the phases from the beginning to the end. But there are aspects that could be industrialized. For instance, there is one that is not easy because it's not easy, but can be more suitable to face. That is the aspect of dissemination, for instance, in which is more clear and more effective the possibility to see what is the strategy that obviously must be determined by the top management on proposal of people working. Is by this way. There are new technologies. Someone audits them, and then the top management is informed and is asked to them to make a decision, a strategic decision for changing, for instance, the dissemination. Also, dissemination is a process with a set of sub-processes. It has an input that are the data produced by the phase of process and analysis, and as an output that is the dissemination of various layouts, various channels, and various perspectives. No? So, this can be driven by the change that are at the technical level, and also by the needs of the users that need more timeliness statistics, more. And by this way, for this particular part, try to apply, for instance, GSBPM in order to model how we would like to implement the new dissemination process, what are the inputs, what are the outputs, and so on. And as far as concerns GSIM, the adoption of one standard for managing data, for instance, SDMX, substantially answers to the aspects of the application of GSIM, because in this case you have the possibility to model data in a multidimensional way, as we have seen previously, by defining a data structure, a reusable data structure. So you can apply the mechanism of reusing code list classification to harmonize them if possible. It's not easy, but if possible. Use international classification and so on. So the application of the standards, the implementation standards, facilitates this aspect that you have seen. As far as concern how long is process, it need some year. Not a process that in 2-3 months, because if you have seen the maturity model previously, if you start from the pre-implementation phase, you have to face, to encounter many other steps, and for instance, you can find a big amount of software free of charge to be applied, the software of Eustat, but also the software of OECD, the software of Eurostat, that allows to implement SDMX standard for dissemination, data exchange, and so on. So you say, very good, it is free of charge. let's take and try. Then you can see that it's not free of charge because you have to spend for capabilities. You have to have a suitable infrastructure. You have to convince the people to change the way to approach the work, the production. You have to recruit some new features, so new skills. So in my experience, because I work on this field from 15 years, now we are reaching a real maturity about these aspects. So it's not a process very, how to say, very fast. But I think that it can be implemented step by step. For instance, starting with a pilot phase, trying to install some of the software for internal use, and then check if it's okay. Not, in my opinion, are not needed 15 years, but 3-4 years in order to have a situation that you can publish externally could be necessary, because, for instance, you have to migrate. Very likely, if you go towards this new architecture, it's possible that you have to migrate your content in these new platforms. There are facilitation instruments, but it depends on the architecture, on the legacy, and this is work. So, yes, it is necessary, and it is not think about a few months, and can be phased for single parts of the whole statistical process. For instance, another point, as I told you, can be the data collection, but also here is not easy because must be selected an instruments used for all the statistics, for designing a questionnaire, or for collecting data from registries, and so on. So, in my opinion, these 2 points are the most easy to for starting. The internal part can depend very much from the statistics. For instance, now, with many difficulties, has been defined a standard for process and validation, that is the VTL, but honestly, I haven't seen only prototypes, not real implementations, because in this case it's important to have a solid platform to be used to use this type of software and to consume this type of standard, and at the moment it is not present. So there was another question, or both? Okay, there was both. Okay, thank you. Okay, so if there are no any other questions, I start. Let's change scenario, and let's start. No, it's preferable. It's preferable to start with DDI. DDI means Data Documentation Initiative, is an implementation standard, and as born in the context of academic organizations and research organizations for collecting scientific data in standardized way. Okay. Is used for describing surveys, questionnaires, statistical data files, and is used in various economic and sciences contexts for as born for collecting study-level information, so collecting data for investigation about various scientific fields. The overall information of this standard is available on the DDI Alliance website. The DDI Alliance is the set of organization that manages this standard, and there is the website related to DDI, that is this one, in which you can find all the information, including software that you can use for applying this standard. Okay, I come back here and here. The DDI Alliance is in charge for the governance of the standards and makes all the tasks related to a set of organizations that govern, chairs the standard. So take care, obviously, of the continuous development of DDI and the related products, promotes the adoption of the DDI metadata standards, supports the development of training programs, and also in the website you can find a set of training initiatives to which, if you want, you can participate. I'm not sure that are free of charge or all free of charge, but okay, I have to. You can close if you want. Yes. And you can. It's for the people, right? Yeah. Yeah, for the remote people. Okay. Yes. And ensures compatibility with DDI standard with other emerging metadata standards, for instance, SDMX, and chairs the activities of diverse community of stakeholders in order to have a process of evolution of the standard that is open, transparent, consensus-driven, and so on. The DDI features, more or less, are the features that we have already investigated for the conceptual standard. The possibility to have a common language for describing data and metadata. Integration of concept, variable, classification, quality. There are many tools available, honestly, not many free of charge, in the sense that, for instance, the best suite for managing data and metadata with DDI is Collectica. Collectica is not free of charge, it's very expensive, and has some module that is free of charge, that is the reader, so the possibility to read questionnaire and metadata sets created in DDI, but the module for design, the repository, the platform for disseminating, for exposing a questionnaire or for disseminating data is not free of charge. Then there are other platforms as Nestor Publisher and NADA that are free of charge or partially free of charge. We will see later an example from Nestor Publisher. But anyway, it's not easy to find completely free of charge software for DDI. DDI, as SDMX, guarantees the reusability of the definition of the metadata and the possibility to use metadata with the mechanism of the reference, so define once, use more, and supports metadata banks, statistical metadata-driven processes, and later we will see why. A survey life cycle, statistical documentation, and discover information, and multi-language approach. DDI has born substantially at the end of the last century. Particularly, the first version of DDI has been defined in 2000. Previously, has defined a set of metadata and the possibility to describe the information according to this metadata in a format that was as GML. GML is the father of XML, is a language for generating markup languages. Now we have XML. And in 2000, has been published the DDI version 1. In the 2003 has been formalized the set of organization, the alliance among the organization that created the known DDI. And always in 2003 has been published the one of the version that is currently used, I think the most used version for DDI, that is DDI2 codebook. In 2008 has been defined the new version of DDI, that is DDI3 life cycle. The DDI3 is not the continuation of DDI2. these are parallel in the sense that continue to live independently each other. So, because have different scopes substantially. Okay, for the production of statistics, we can find the concept that we have seen previously. We have the study in statistics is not used only in statistical concepts, contexts, but represent in statistical context the survey, the survey. And this survey measure a set of concepts about universities. And in order to do this, use survey instruments, particularly questionnaires, that are made by a set, composed by a set of questions that are the part of the question. The set of questions collect responses that are put in a data file. This data file are made by instance variables that represent the instantiation of the variable, so the representation of the concept inside a data set, a data file. The enumerated variables can have values coming from categories, code list, or if are measured variables, numbers. Then, once the data are aggregated, we can have multidimensional data sets in which the variables, to the variables is associated a role identifying, and in this case we have the dimension, or a role of descriptive role and we have the attributes, or represent the measure, so the concept associated to the set of values contained in the data set. And in fact, this structure is used for defined multidimensional hypercube, also in physical terms, so inside the database. DDIC and DDIL. DDI has two development lines, as I told you. DDI codebook, DDI2, and DDI lifecycle, the DDIL. DDIC is used for creating codebooks about studies. So we will see an example of codebook, but it is a document containing the description of the survey and then containing the description of the variables defined for used in the survey, with associated the enumerated values, so substantially code lists or classification and similar. And DDIL focuses on a more inclusive life cycle model. Substantially, DDIL is used for representing the data life cycle in all the phases in which the data is collected, worked, processed, and disseminated. Characteristics of the DDIC, that is the early DDI, but is still very much used, is focused on the static object that is the code book, is designed not for being used in all the data life cycle, but is used for documentation purpose in order to facilitate the data discovery in the scientific context and also in statistical context via the focalization of the variable. The coverage is focused on single study, single data file, simple survey, and aggregate data files. So the input data file is only one from which is possible to document the structure of n data files. The variable is the central element that contains the majority of information, question, categories, data typing, physical storage information, and also statistics on the occurrences of the variable, for instance, in the data set. DDIC it doesn't support the data collection process. It is only a documentation instrument. So it's an add-on of the data collection. Focus is on the data and the product and then the user is for searching information about data set. There are not many tools for the creation or exploitation. The variable must exist before metadata can be created because this is a static standard, so doesn't support the information for the creation of new variables, for instance. Some producers of data are hesitant to use it because it implies a big effort, but doesn't support the data life cycle and particularly the data collection. DDIL is different in the sense this is designed to meet a broad set of requirements, but substantially it covers all the data life cycle, emphasizes the reuse of metadata, and can be used for creating, implementing metadata-driven systems. Okay, this is an example of the types of metadata in DDI lifecycle. We have, in addition to concept studies, variables, code and category, that we can find also in DDI-C. The particularly is that DDIL has also the metadata for questionnaire, the survey instruments, the question, and the responses. DDIL model is this one, starts from the study concept, then data collection, the processing, data distribution, discovery, and data analysis. So we can see, and then at the end, last but not least, the data archiving. This is, as you can see, a structure that is very similar to GSBPM, but there are some differences that must be considered. In the GSBPM, the base aspect is that the process is carried out by only one organization. It is not the same in the DDIL. Because in the DDIL, as you can see, we can have, after the data distribution, the phase of data discovery. Data discovery means that someone outside the organization needs to discover the data. And also the data analysis is put at the end of the chain. Instead, if you see, the GSBPM is before the dissemination process. This means that also this data analysis substantially is covered outside the organization, and it can give an input, for as a loop back for data processing, in the sense that if an organization collects the analysis of data made outside from the stakeholders, for instance, it's possible that it can be used for processing data, and then once processed, redistribute to the stakeholders or to the users. And then there is another phase that is not covered inside GSBPM, that is this one, that is the archive. Instead, in the DDI, it is possible to consider the phase of data archiving that is used for maintaining the storage of this information and make an historical reconstruction of the information along the time. Then another aspect is that in the DDIL we don't have data dissemination, we have data distribution. That means that data dissemination is a broadcasting provision of data. Data distribution implies a point-to-point mechanism that can be considered. Okay. Data discovery and data analysis in GSBPM are put in the analysis phase 6. Okay, GSBPM places the data archiving towards the end of the process. Instead, in this case, is put substantially before. The GSBPM identifies explicitly the overarching processes. In DDI model, they are implicit. Okay, the relationship among GSIM and DDI is based on a set of objects that are implemented in specific profiles. So these specific profiles can be a base set for DDI elements for interoperable use. We have the variable profile that cover the GSIM objects that can be used, consumed by DDI for managing variables. The same is for the represented variable profile used in DDI for implemented in DDI for supporting the represented variable, the enumerated value domain, the described value domain, and unit measure. The questionnaire profile that is translated in DDI in the profile for building business questionnaire, and the code list profile that in DDI is implemented as objects to support code lists and category sets. DDI as SDMX follow the ISO 11179 W3C recommendation. The ISO recommendation 11179, and this means that the objects in DDI are univocally identified by three information: an identifying code, a maintenance organization, and a version of the object. The same is in SDMX, in which, for instance, each metadata element, called artifact, is identified by ID identifier, agency that is the owner of the metadata, and the version in order to maintain a congruence of this information, particularly in case of data exchange. So, as we can see here in a comparison among DDI-C and DDI-L, substantially the most important aspect that is different is the fact that in DDI-L is supported the creation of the questionnaire for the part that can be of much interest for us. In DDI-C, substantially no. There is a common part related to the aspects of study, data repository, variable list, and so on, that is common among these two standards. What are the possible use cases in implementing DDI? We can consider three main use cases. DDI use case 1, how to build metadata for a questionnaire. Second one is how to build metadata for a unit dataset of elementary data. And the third one is how to build metadata and data for a multidimensional dataset. The metadata, the scope related to the use case for creating metadata for questionnaire is to define this metadata once and use more. So the concept is to strongly apply the reuse. The reuse of what? The reuse of questions, for instance, of concepts, all the entities and the parts that can be used for building a questionnaire in order to standardize and industrialize the data collection, generate possibly in automated way the documentation in various formats that can be PDF, Word, HTML, and populate key system, but there are no software developed directly by the DDI Alliance, but there are softwares as Blaze or other system that can consume this type of questionnaire and collect the responses. Metadata for questionnaire. It's possible to define a questionnaire by creating a repository of questions that can be simple questions, as this one, or multiple questions, complex questions. Did you pay work last week, full-time, part-time, how many hours? So it is possible to define a very large scale of question types that can be managed by using DDI. A multiple question item can contain question items or multiple question items. The questions can link to one or more concepts. In fact, are used for capturing information about a specific concept that can be age, sex, country, what is your age, your sex, what is the country in which you live, and so on. These are all information that can be used, that are linked to specific concepts that we want to investigate about a specific population. In DDI, questions have a name, multi-language. DDI as SDMX supports multi-language in a generalized way, so it's possible to define and use how many languages as we want. A text. The text can be, for instance, the question asked, can be also conditional, multilingual, and also formatted. And the question intent. Question as the variables have a response domain that can be of various types. We can have numeric domains, and it's possible to define the type integer, decimal, text domain. We can indicate format or length, and also category domain, so a set of multilingual variables, values, that can be associated as a response to the question. Code domain in case in which the category domain is coded, so we have a classification, a code list, or similar. The questions are collected in sort of repository that can be used, in which the question can be used for building different questionnaires, if you want, without replicating them. And the questionnaire in DDI is called the instrument, but the questions are not directly connected to the questionnaire. but are selected and assembled into an instrument by using a construct that is the control construct. Control construct gives the flow of the questions. And then is used for defining eventual branching, eventual looping of the question, select the question to be used, can link to interviewer instructions that can be instruction structured or unstructured, so for instance, material that can be given to the respondent. But anyway, control construct substantially is an entity that contains the regulars for the rules for defining a questionnaire, the flow in a questionnaire. And we can have different type of control construct. There is a question construct that select a question item or multiple question item, a sequence construct that can select a sequence of other control construct, because a control construct can define the relationship with other control constructs. Then there is a conditional control construct, substantially implement the condition with if then else, or a control construct for cycles based on loop, repeat until, repeat while. Statement item that is used in a questionnaire for inserting a non-question multilingual test, a computation item, a calculation that is assigned, can be assigned to a variable. The instrument identifies, the instrument is the questionnaire, identify a main control construct that can call the other, and this can be a recursive mechanism in general way in order to define the flow of the questionnaire. Then there are the instructions that also are a formal DDI metadata that can be organized in structures as formatted multilingual text, can be also conditional in the sense if you respond to this question, then read this how to say, this instruction for continuing the questionnaire, and may link to external, not DDI material. This can be an example of questionnaire template in which we have a set of submodules. There is, we can imagine that there is a main control construct that calls the main module of the questionnaire. Then each of these control construct can call other control constructs then in order to define all the flow of the questionnaire. Control construct is not a function, is an information, is an entity of metadata that can be consumed by an application, can be read by an application in order to define the flow. So you have to consider that this is not a programming language, DDI, but is only a language for defining metadata, and control construct is an entity as the question that is used to define the flow of the questionnaire. So the steps for creating and publishing a questionnaire are the following: the definition of the concept that I need to investigate, gender, age, education level, the categories and codes that I would like to associate for each concept. Then at this point, I can define the question, a reference to response domain to be associated to the various concepts, create the instrument that is the questionnaire by defining the related control construct and the question that I would like to use, produce documentation and publish in the portal in various forms that can be documentation associated to the questionnaire as document, PDF, Word, and then publish survey. Then another use case, in addition to the possibility to create a questionnaire, is the use of metadata for unit dataset. That is something similar to that we have expressed when we spoke about GSIM, in which we have the dataset composed by a set of instance variables that are the columns of the dataset related to the concept that is investigated inside for obtaining this set of data. The variables, instance variable, are connected to represented variable that is connected to conceptual variable and to concept. And there is, as we told, associated to the represented variable, a set of values inside that is containing in the value domain. Okay, this is also indicated in this conceptual model. The logical record is a combination of the values for the sequence of variables that are part of the data set that identify data values for a specific purpose. Logical records are independent from the storage, from the database that we use, or technical instrument that I use in order to store it or to process it. The physical instance is related to the specific dataset inside a specific stored in specific platform in specific instrument, and links to physical structure. For instance, we can imagine that a dataset, instance dataset, is inside the tables of a database. In the columns usually represent the various variables, the various columns. Okay, the classification and code list are the same that we have seen in GSIM. So category scheme is a list of categories of item of the value domain without code. A code scheme means that the set of values, the values of category scheme are associated to a specific code that is alphanumeric usually and not multilingual. And the code scheme may specify also a hierarchy. As far as concerns the use of DDI for multidimensional database, it is related to the possibility to document, also in this case, variables inside a multidimensional data cube as this one that we are seeing, in which we have a set of components that are identifying, describing, or represent a measure. For instance, in this case, we have the identifying components, so the dimension variable that are gender, is married and has a car. We have the measure that represent the count of population, and the footnote specifying some attribute for its value that is descriptive, so is representing as an attribute. This classification of the components we will see tomorrow also by using SDMX allows the possibility to manage in a very flexible way the data, also for representing them in specific layout as that one that we can see here, in which it's possible to tabulate this table that we can consider vertical, called normal, in which we have only one value for each record, in a pivot table in which on the side we have the gender, and on the head we have marital status, and in the body we have the data. Okay. Yes, we have already spoken about dimension, measure, and attributes. I suppose that we know very well now that dimension are identifying variables, attributes descriptive, and measure list of variables related to specific values. And this is the reference that we can find if you would like to go inside more on DDI Alliance. About DDI, I would like to show very quickly. Okay, it's visible also here. A pair of example by using a specific instrument. This is Nestor Publisher, that is this part, the part for the back office is free of charge, but the platform for publishing is necessary to buy it. And in Nestor Publisher is possible to define code books. So, for instance, I have created as an example a code book for consumer prices, in which here there are the information of the code book. If I explode, there is the description of the study with the information, title, name. These are all metadata that we can insert for defining the general information related to the study. Other blocks with this citation, if the producer or the funding agency, in the case I put Eurostat, then it's possible to put some keywords and the topics connected to the study, that is in this case consumer price. Aspect related to the methodology, for instance, sampling procedure, mode of data collection, weighting, and so on. And then the documentation of the data. For instance, we have a data set of data about CPI in consumer price in 2021. If I click on variables, I told you that in the code book, the variable is the central element. So if I click on this, I have all the information that are related to the variables inside this data set. For instance, the frequency of record in which this is the, no, let's start from the variable with the information of the position inside the data set. Here there is for each variable the category set. In this case is the territory. For instance, the associated to the ref area, this is the territory of Italy. The same is for indicator for all the enumerated variables that we have here with the related code list. It is here we have the frequency of occurrences of each value for this variable inside the data set. It's possible to indicate the documentation also with information related to the question of the questionnaire that is associated to that variable. And it is possible also it is possible also to take, for instance, the data set, that is this one. These are the data that are stored inside this data set. Through this instrument, I can also define some aggregation consuming the information that I have inserted. For instance, if I click on this, I can make an aggregation by using ref area and I put the break values, and the same for indicator. And I can decide for the values what type of aggregation I would like to applicate, considering in this case the possibility to have the average value in aggregating this base data set for ref area and indicator. And then I can click on OK. Oh, sorry. We have let's try again. Indicator is black. Aggregate on all levels. Sorry, I clicked. And I have the representation of aggregated data with the values in average strategy. Okay, another example can be related to Collectica. This is a plugin that Collectica Reader I cannot unfortunately show you. In the next the other aspect that I would like to highlight is that I can export in DDI the documentation. So substantially is an XML that I can open and contains all the meta information related to this consumer prices study. And the aspect that I would like to highlight is that this is a very old version, is 1.2, but substantially this is a codebook version of DDIs, not the version 3. Coming to Collectica, in this case it's possible to install, to download from the Collectica website a plugin, that is this one, in which is possible to document a data set. Okay, no. For instance, if I go here, okay, and it's possible for each variable to select it. You can see that I have a column from this data set related to FREC. I can put the label. I can put the data type. For instance, I can say that is a coded column. So I can indicate that I would like to use, to create a new code list and update codes from data. If I go here, it takes the value that I have in the column, for instance, M, I put monthly, and I can do it for each of them. Let's take from another. So ref area, territory, data type coded also in this case, create a new code list, no. I can use, if I have already defined the code list, I can reuse. For instance, in this case, previously I have defined the ref area code list. I can select from this and I can use here. I can put some labels if I don't have, for instance, Italy, North. This is the territory of Italy, northwest, and let's stop here, Piemonte. Okay. And in this case, I can save as DDI or create a document workbook. And in this case, it should export this or save as DDI, and I can put this, for instance, CPI. XML. Just to check if it is created it. No, it's strange. It seems that okay, this should be this one. No, this is data. I don't know why. CPI, EDI, and document level. Okay, let's search in document. Okay. Okay, this is the representation of the data set that the metadata for the data set that we have considered in DDI3 that we can see here. And this is another example in which we can apply the use of DDI in this context. So, okay, I don't know if are there questions for DDI? No? Okay, so I pass to the part related to the SDMX. I don't know if we were able to complete in this morning all the general parts, but anyway, okay. Okay, let's start with the introduction to SDMX. SDMX is another implementation standard for the exchange of data and sharing of statistical data and metadata among the organization. Also, SDMX facilitate, for the reason that we have already expressed many times, the modernization of the modernization of statistical processes. The advantages are the classic advantages to be applied when we speak about a standard statistical standard for sharing data and metadata, so harmonization and coherence of data, preservation of meaning, the possibility to use open formats associated to the output of the standard as XML, JSON, CSV, RDF, can be used by international standard as building block in internal statistical IT system, can potentially reduce the cost of developing statistical software because there is very much free of charge software that can be used in order to implement the data dissemination and exchange based on SDMX, and is used as an implementation standard because it's possible to build systems based on these standards. The enablers of SDMX can be the following. The top management in the sense of planning and modernization programs, the domain manager for how to say, organizing the application of this standard for various purposes, as for instance data exchange, this is very classic, or data reporting to international organization, but also dissemination. And anyway, it increases the use of metadata within the whole data life cycle. In technical terms, the application of the SDMX can mean the reengineering of statistical business processes, the possibility to move out from legacy database, reengineering of legacy information systems, and we will see how, in the sense that it's possible also to wrap the legacy information, the legacy database, for instance, to be disseminated, and whose data can be disseminated through SDMX instrument, and build an SDMX IT cross-cutting architecture with the main aim to reduce maintenance and support. The main use cases are metadata management, data warehousing, reporting, as I told, that can be push and pull. Push means that I send the data. For instance, the classic push can be to send a data set by mail, but now, for instance, in the data collection from Eurostat is currently used a specific platform that is called the dummies, in which the file is put by the organization and collected by Eurostat. Pull means I make available the data, for instance, through a web service, and when the collecting organization decide to take them, to grab them, it connects to the web service and grabs them without expecting that I send the files. And validate data using XML schemes and the standard VTL for validation and transformation languages. There are many SDMX projects along the world, particularly of data collection from international organizations like Eurostat, that collects many data from the member states in SDMX, but also the exercise of IMF for SDDS Plus for collection of macroeconomic data for the Monetary Fund. the Sustainable Development Goals of data collection in SDMX from United Nations. In last year has been the European Census Hub for transmitting, from making available from member states data to Eurostat in a pull mode, in the sense that there is the central application that calls the various web service according to the selection of the users and extracts the data, and the Eurostat data collection, short-term statistics, CPI, and so on. As far as concerns the history, SDMX has born more or less 20 years ago, and there has been issued many versions. The last one has been issued in 2024, that is the 3.1. In the September 2021 has been issued the 3.0. But in this moment, I think that the most used version is the 2.1 that has been issued in 2011, because there are many software development from this date that implement this version of the standard. In 2013, SDMX became an ISO standard with the ISO recommendation 17369. As far as the governance of the SDMX has been founded by 7 international organizations, in which there is World Bank, Eurostat, Bank of International Settlements, OECD, European Central Bank, and others, and is organized from a sponsor a committee, steering committee from sponsor organization that is composed by the chief statisticians of this organization. There is a secretariat for the activity of the SDMX consortium that chairs particularly the activity of 2 groups, the statistical working group and technical working group. Statistical working group is working group that gives the how to say the guidelines for defining data structure and metadata structure according to the SDMX standard. It governs the maintenance of the SDMX global registry and define and evolve the content-oriented guidelines. The technical working group is involved in the technical activity for defining the rules to apply it by the system for implementing various SDMX formats as XML, JSON, and so on. Improve the technical documentation, maintain and evolve the global registry, and interact with the other technical standards, as for instance DDI. The main components of the SDMX are these 3. 1, the information model, the content-oriented guidelines, and obviously the infrastructure, so the software that has been implemented for exchanging, data exchange and sharing. The SDMX information model means how the information can be organized in this standard. and covers all the set of metadata types that can be used and all the rules that can be applied in using these standards for exchanging data and metadata. The content-oriented guidelines are not rules, but are recommendation and description of best practice in order to define, for instance, various entities as code list, concept scheme, category scheme, so all the metadata entities that can be applied, and define also cross-cutting specific concept. Tipo defined a team tree that can be used for, in general, for categorizing dataset in SDMX. Some shared code lists, for instance, the code list of frequency, monthly, quarterly, and so on. And the IT infrastructure is all the software that can be used in order to apply SDMX standard. I don't know if I can change all of this information you can find in the SDMX SDMX.org. And particularly here you have the description and of the information model and all the rules for the standards in the standard tabs. In the guidelines there is the list of all the content-oriented guidelines that you can use. Another important thing is the tools, because here you can find all the toolkit and the tools that has been developed for using SDMX, and there are very many and really free of charge in the sense. Developed also by big consortium or as the Statistical Information System Collaboration Community chaired by OECD. There are software developed by Bank of Settlements, International Settlements, and here at the end there is also the SDMX Eustat toolkit developed by Eustat. SDMX is able to manage structural and reference metadata. Structural metadata means metadata for the description of the data in terms of structure, so data structure definition, code list, and set of concept, set of categories, so all the metadata that are used in order to manage the data. Reference metadata are specifically data related to the statistical process, to quality, to the methodology that has been applied to a survey in order to produce a specific data set, and so on. This is a graphical representation of this aspect. Substantially, we have the DSD, that is the data structure definition, that defines a data flow that is the conceptualization of a data set, in the sense that in SDMX the data flow means that a data set is associated to a data structure definition, that is the DSD. The data structure definition can be used in order to define the structure for many data sets, as I told you previously. And the same happens also for data structure definition, that allow to define the structure of the metadata set. The metadata structure, the metadata set substantially is a document. Is a document that contains the information about the metadata associated to the data. So the metadata structure definition is a template that this template can be reused for many metadata sets. And the metadata flow is the element that means that a metadata set is structured according to a specific metadata structure definition. But all the SDMX metadata, as the DDI metadata, are based on the reuse, the possibility to be reused and referenced in the description of data or of reference metadata. This is the representation of the package of the information model of SDMX. The package has a base layer that gives the specific rule for defining all the type of SDMX metadata. Also in this case, as in the DDI and according to GSIM, each structural metadata has to be identifiable, versionable, and maintainable. So for identifying univocally is necessary to give an ID, a version, and an agency organization that maintain the artifact. And there is the layer related to the various type of structure that I can define in SDMX. So data and metadata structure definition, concept and category scheme, code list, provision agreement, hierarchical code list, and so on. In the upper layer, there is the definition of the data set based on a structure defining the data structure definition, or a metadata set, that is the part related to reference metadata, based on provision agreement and other metadata as data flow and data structure definition, code list, concept scheme. Is possible to define subscription and notification, to make a registration of a specific data flow inside the registry. Data flow is the blueprint of data set, so I say a collecting organization that I will give data about this data set, and this, the entities for data and reference metadata discovery. Okay, this is the graphical representation of it, in which there is the representation of an artifact that is maintainable, so is associated to an agency, versionable, so as a version for each instance of this metadata. Nameable means that it is associated a multi-lingual name. Identifiable, that is associated an ID. And a notable means that it's possible to associate to this metadata a general construct that is called annotation, that can be used also in semantic way in order to enrich the information that can be exchanged. For instance, tomorrow, I suppose, we will see an example of use of annotation as a layout annotation for representing dataset in visualization. For instance, annotation that says how is structured a representation of data flow in a table. Okay, this is the same. And this is the schema of the SDMX information model that already we have explained. At the center we have the data and metadata flow, that is the blueprint of a data set or a metadata set. Each data and metadata flow is associated to a structure, and the definition of the structure references. The structure is composed of a data set is composed by components with their role, dimension, measure, and attributes. And each component, if coded, is associated to a code list, but each component, independently if it's coded or not, is associated to a schema. A data or metadata flow can be categorized, also this one we can see tomorrow, in the sense that it's possible to put it under a specific category of category schema, that means a team tree, and for data exchange can be associated to a provision agreement through the definition of constraint. The constraints means the rules for defining what part of data set can be exchanged by putting some specific filters of the values of the dimension. Okay, the concept scheme is a container of the concept. The concepts are the concepts that we have seen in GSIM, in DDI, so the representation of a characteristic that we would like to represent in a data set, characteristic that we have investigated in a population. The code list is a set of values in the value domain of represented variables that are coded, and a category scheme is a set of teams and subteams through which I can categorize my data set. Then there are other as agency scheme, data provider scheme, data consumer scheme that are used in data exchange in order to indicate the organization that are data provider, data consumers in exchange, or inside the organization what are the part that are owner of specific data set. So for instance, we have the organization unit scheme. This part we have already explained. So this is a graphical representation. Now is structured the data structure definition. We have the DSD composed by a set of components. Each component represents a concept with a role. The role is, if the concept is identifying, we have the dimensions. If the concept is describing, we have an attribute. If the concept is related to value, we have the measure. Each of the component is associated to a concept. The concept can be collected inside the containers that are called the concept scheme. A concept scheme can be used for defining many DSDs. And the same is for the code list. Okay. Also this one we have already expressed. The DSD describe a data flow. The data flow contains as many information that is structured according to a specific DSD. Then putting to the data flow specific constraints of dimensions, so putting substantially the filters to the data flow on the variables of the data flow, we have various data sets. It's the same, more or less, for the MSD. Okay, how is possible to model data in SDMX? First of all, as we have seen previously, we must identify the statistical concept that we would like represent in a data set. And once we have identified the concept, territory, age, indicator, sex, whatever, frequency, we put all these concepts in a container that is called the concept scheme. Then, once we have consolidated this container, we can finalize it. So once an SDMX artifact is finalized, it is not possible to add new elements, but if we would like to add new elements, we have to change the version of the artifact. Then we can define representation for each concept, determined by the values of the domain value related to the concept, so to the conceptual variable. And by this way, we create code list. The mechanism is the same for the finalization. Also in this case, once we have consolidated the container of the values for that concept, we can make them stable, and if we want to add new codes to the code list, we have to change version. Then assign a role to each concept, so to put a measure, dimension, indicate if a concept is a measure, is a dimension, or is an attribute. Attributes can be mandatory or conditional. Mandatory means that in a data set, for each record they must have a value. Conditional is not necessary that they must have a value for each record. And this is an example of statistical table modeling. We have a farm average indicator by turnover class. Annual data. We can see that in this modeling, the frequency is not in the table, is outside the table. On the left, we have a set of indicators that are on the side of this table. Then, in the head, we have the time period, and we have another dimension that is the turnover class. And on the side, we have an attribute that is the unit measure, and another attribute it's outside the table, that is the observation value. Another one again is the source. We can see that these attributes are not identifying of the data cell, are only describing the data source, in this case National Statistical Institute of Italy, and then we have the observation, the measure, that is the body of the table. As far as concern reference area, in this case it's not explicitly represented in the table, but we can imagine that in this case the territory can be represented at a national level, for instance in case of Italy, Italy. Okay, so by this table we can extract a set of concepts for dimension, attribute, and measures that are those that we can see here: frequency, reference area, indicator, turnover class, time period, observed value, status, unit measure, and source. And these are collected inside an entity that is structural metadata concept scheme, the farm indicator concepts. For the code list, we can see that the major part of this concept are associated to a set of values, so to enumeration, coded values that are those that we can see here, And by this way, it's possible to define for each set of values, for instance, those or the indicator of those or turnover class, etc., specific code list, but also for the unit measure, in which we have a code and multilingual name, as we can see represented substantially here. And here we have put together concepts and referenced code lists. Is it already a data structure definition, this one, yes or not? The response is not. Why? Because here is necessary to give a role to these concepts. And the role is defined as we have seen previously: green are dimension, red attributes, and blue measures. So, by this way, once we gave as very likely we can see here, in the lower part, there is a column of role that says dimension, measure, and attribute. By this way, it's possible to define a DSD. Now we have all the elements to define a structure for the dataset that underlines this table that we have seen represented here. At 2 o'clock, I don't know if we can stop. Okay, we continue. Okay. No, for me it's okay, very okay. Okay, statistical guidelines, content statistical guidelines. The content-oriented guidelines are used for the harmonization of terminology, code list, and subject matter domains name. These are not part of the standard rules, but are part only, are a set of best practices of contents that can be used in order to harmonize the representation of the data sets. We have a list, but you can find the complete list here, as I told you previously. If we go to guidelines, you can find all of those. And there are many, as you can see, for various aspects: annotation, metadata reporting, modeling statistical domains, data structure definitions, and so on. Each of them is used in order to guide the activity related to the management of data and metadata in SDMX. And they provide also specific elements, so there is a standard concept scheme with the common concepts, and the code list for the frequency and for other cross-cutting code lists that can be used in each of the data sets. Okay. Okay, they include introductory document, cross-domain code list, as I told you, also the glossary that you can find in the sdmx.org here. It is a document in which there are all the terms that can be used in the SDMX metadata with I hope it will open. Okay. When it is going to open, I can try to go further, or the other thing that I can do is download it. Okay. And you can see here the glossary, in which each term compliant with SDMX is represented with definition, context, concept ID that we can find in the cross-domain concept scheme. The code list associated, related terms, and the source. This is valid for each the term that we have here. Okay. And also the classification of the subject matter domains. There is a category scheme, standard category scheme with the main themes usually adopted by the SDMX users. This is the glossary, as we can see, we have seen previously. Architecture and tools. The most important architecture is related to the SDMX registry. The registry is the repository of SDMX metadata and provide information for accessing to data and to reference metadata, and contains all the structural metadata that are defined usually at organization level. There is also a global registry that is possible to consult if you go on the internet. It's possible, no, sorry. SDMX, otherwise it finds. Okay, and here you can find are defined by this is the registry of the consortium and contains many data structure definition, particularly used in the global data collection. For instance, here is the list of all the data structure here, and it's possible to download this artifact also in the latest version of SDMX, so the 3.0 version. And obviously for each of these it's possible to go to the detail and open the structure of DSD. If I click on this, I can see all the dimension, measure, attribute, and so on. Okay. This is a classic registry architecture in which there is a metadata repository. Usually there is a service, a web service, that allows to query a registry in a machine-to-machine mode in order to get the metadata, and can be applied an interface that usually consumes the register, the web service as a backend of the application. This is substantially the architecture of Eurostat for collecting data in pull and push mode by using SDMX. In case of pull, the member states expose an SDMX web service, as in the case of the Census Hub. Instead, the push mode is based on the transmission of the dataset by the member organizations by using a platform that is called the dummies to Eurostat, obviously. And then there is an intermediate storage that contains the part of data processing, aggregation, and so on, and then there is the dissemination data warehouse with the related web GUI for the visualization and browsing of data. This is an hub architecture instead that is possible to implement. Eurostat implemented it in the Census Hub, in which if you go on the Census Hub website, that is this one, you can I hope to find easily the link because let's check by this. Okay, this is the Census Hub. When we make some selection here, we can see this list of countries. Each time is selected one of these country and selected the variables that we would like to browse. For instance, I don't know, sex, age, and I can go to let's start this way. Okay, for instance, select Italy, and then select here, then go to next. Okay, you can see that this way is preparing a query to the system, to the web service of Italy in this case, and we can click on displaying data. In this moment is querying a web service from Italy. It's not so fast, but anyway, at this point when it finishes, but it is a real-time query in this case. Very likely, I don't know if it is a query very, very big, but anyway, okay. Continue, sir. Okay, this is an example of an hub architecture. In which the user makes a query to the, in this case, to the Census Hub. This is the SDMX query. And the query is distributed to the institutes that are the nation that are queried, are selected before doing the query. Then the web service makes the query to the database and returns the data inside the user. And this is an hub architecture that can be provided by the hub architecture, and this is the result that can be seen. Anyway, if you would like to see an example, you can see the census hub architecture that we have seen previously. So also for this introductory part, we have, I suppose we have completed. I don't know if there are questions about it. Okay.
No, I think it's okay if there are no questions, and we can finalize the day, maybe.
Okay. Okay. Yes, we can finalize this first day by saying that we have seen in introductory way the part related to the with the scope of an overview of instrument for modernization of statistical data. The part we have seen the part related to conceptual standards that can be used, so GSBPM, GSIM, and also we have had an introduction related to the implementing standards, particularly DDI and SDMX. And tomorrow we will see in action how can be used SDMX for managing and publishing data and metadata.
Okay. Thank you very much. So we'll see you tomorrow, and after this intense morning, I hope you have enjoyed it and learned a lot. And you know that this is not only for doing nice things. This is to improve our job in terms of modernization so that we can be more efficient and so on. So thank you, everyone here, and see you tomorrow.
Bueno, grazie mille, Alessio. Gauzatxo bat bakarrik. Turismo sailetik bidalei dizkigute, liburuzka pilo bat Euskadin turismo egiteko, bale? Orduan, hor daukazue, hemen justo mai gainean, nahi duzue txirringaz egiteko txango batzuk, edo oinez, edo, visita culturalak edo, ¿vale? Comentaba que nos han mandado desde turismo un montón de folletos para hacer turismo en Euskadi, en bici, andando, visitas culturales. Tenéis aquí encima de la mesa, entonces, cogéis lo que os apetezca, ¿vale? Mila esker.